Is this thing on? Is this thing on? I don't see a light. Oh, hi. My name is Sean Prendergast. Today we're going to talk about multimeters. Okay, let's get you situated in our home workshop here, our kitchen workshop. Alright, two multimeters. We have the little red one, is about a $20 job from a local hardware store. Digital, works great. And the one on the right is Fluke 87, about 300 bucks. So they do exactly the same thing. Unless you're troubleshooting generator sets for frequency, unless you're troubleshooting corrosion issues for very fine amperage or voltage readings, and even still this isn't the most accurate thing, or you need very accurate temperature readings with a thermocouple, this meter is really not even worth the money for what we're trying to do. This is your workhorse right there. I'd rather have 15 of these that I wouldn't cry too much if it went in the water than one of these that my helper dropped off the dock. Okay, so we measure voltage, DC, voltage AC, amperage AC, amperage DC, and resistance. Mostly we're going to use this to test voltage, voltage drop, and continuity. So let's look at those. Okay, so we have a 1.5 volt battery here. To test the resistance, we make sure our probes are in the right place. Common, always black, always stays there. And the red will, if we're testing voltage, ohms, or milliamps, very small amounts of current, will stay on the right side jack. And if we're testing higher amperage up to 10 amps, it goes on the left side. Okay, so to test voltage, we simply turn to volts DC, take our battery and our probes, and we're on the 2000 millivolt scale. We have a reading of 1475. That's 1475 millivolts, not volts. Thankfully, we'd be in trouble if it were 1475 volts. That's millivolts, so 1.475 volts. Okay, use that to test a car battery. Use it to test a 9 volt, an old one, a new one. Put two different color or different type metal nails and a lemon and test that. You'll get voltage. It's outlined in the text. So that basically that's voltage. We're going to use the 20 ohm or the 20 volt scale mostly, and if we're troubleshooting a 24 volt system, in this meter we have to go up to 200, but it's fine. It does the job for us. If we want to test wall outlets, here's volts AC over here. Let's talk about resistance now. Okay, to test voltage, we obviously have to have a potential difference or a voltage in the circuit. We have to have it to test it. When you're testing resistance, you don't want to have the circuit energized. You really don't want that to happen because you'll blow a fuse in the back of the meter. It's not a huge deal, but you usually don't have that smaller type fuse on hand, and it's a little embarrassing if you're with your co-workers. Okay, so we have two resistors of unknown value, and we're in our meter. Now look, the meter says 1 on the left hand side. Okay, when this meter, that means out of range, or what it's trying to measure is out of the scale of the meter at that time. So you usually have to adjust to get a good reading. So first let's test the resistance of our leads. Okay, the resistance of our leads is about 1 ohm, which is great. That's perfect. That's about what we want to see. So we'll take this unidentified carbon film resistor, and this is just for demonstration purposes. We very seldom will see a resistor in a DC electrical installation, but they're kind of fun to measure and to play with and to get to know your meter. That's what it's all about, is just using your meter enough to know what it's going to tell you. Okay, 15.7 ohms. Perfect. Now watch this. I'm not touching the resistor, but if I do, look at the resistance changes. It actually drops. I create a parallel circuit through my fingers and through my body for another path to ground for the meter. So now it usually drops about, say, 1/10 of an ohm when we touch it and when we don't. Kind of interesting, but keep that in mind. If you are trying to get an accurate resistance reading, don't squeeze on real hard. Use alligator clips or something like that. We have another one here. 1. It's either a broken resistor or it's out of range. Let's check. Still nothing. 20,000 ohms. We had a flash, something happened, and then back to 1. 200,000. Alright. Now we have a reading of 46,000 ohms. Not 46 ohms, but 46,000. So you have to keep that in mind, and it's good because it makes you cognizant of what's in the circuit, what you should expect, and what could be kind of a crummy reading. Okay. Another feature, a very handy feature of this meter for chasing down wires or finding circuits are good, is the continuity feature. So we go to a little black diode symbol, touch the leads, leads are good, meter's good, we have continuity. If you have a bundle of wires and you're chasing, say, your stern light wire down, and a bundle of wires, you hook into the stern light wire, the back of the boat, with the jumper lead, and then test each wire until you had continuity, heard the beep, and you know that was in fact your stern light wire. It takes a lot of the guesswork out of trying to decipher a wire harness. Okay, one last thing we'll talk about. These 3 leads over here, these 3 jacks. You can use a multimeter to test amperage, AC and DC. I don't like to do it. The reason is you have to put the meter in series with the circuit, and you have to energize the circuit. That means all the amperage in the meter, or all the amperage in the circuit, flows through the meter, through the leads. So if you have a spike, or if your amperage is over what you expect it to be, you're going to blow the fuse in the back of the meter. To measure amperage properly and a little more safely, I prefer an inductive amp clamp, which we'll talk about in the near future here. That's an introduction to your meter. Use it, measure different things this weekend, get a path of resistors and make a train of resistors in series and parallel, and just get to know your meter.